A quick overview of the calculator. This calculator is for humidity calculations using the ideal gas law. On the left side we have the inputs, and on the right side we have the results. The results can be individually moved to match the user's preferences. We also have the settings menu where we can select and deselect any of the parameters we want to see. We can change the results, for example the water vapor pressure, we can change that to any of the pressures listed below. And we can also change other options such as the WMO-RH, which forces over water calculations. Pressing the question mark button will give you more information about the parameter or the setting. Example 1. For this example, we need to find out the relative humidity of a dew point of minus 10 degrees Celsius at a temperature of plus 40 degrees Celsius in air at atmospheric pressure. First, we will select the known parameter, which is dew/frost point. Selecting this parameter will allow the calculator to automatically select if it's a dew point or a frost point. Usually, if the dew point is less than 0, then it will be a frost point. However, due to a phenomenon known as supercooled water, and in some elevated positions where atmospheric pressure is less than what it is at sea level, it can exist as a liquid below 0 degrees. We can force over water calculations in the settings for these cases. We will then enter the known frost point of minus 10, selecting the temperature of plus 40, making sure it's in air, and then we press calculate. As you can see, we have a relative humidity of around 3.5. Example 2. Calculating the dew point at different pressures. For this example, we will stick with the minus 10 dew point at atmospheric pressure and then increase the pressure to 7 bar gauge and see the effects of pressure on the dew point. Technically, this temperature should be a frost point, but in the industry it's pretty interchangeable. First, we will select the parameter and enter the dew point, making sure it's at atmospheric pressure, 0 bar gauge, and we'll press calculate. Then, in the pressure compensation, we will enter 7 bar gauge, and we'll get a resulting dew point of 17.9 degrees. And the frost point is not available as this is above 0 degrees Celsius. Example 3. Calculating the maximum absolute humidity before saturation occurs using ppmV or percent volume. For this example, we want to see what the maximum amount of moisture is before saturation occurs at 21 degrees Celsius. To do this, we will select the ppmV parameter and the known unit as percent volume. We will turn the pressure compensation off by typing in 0 and entering 21 degrees Celsius. We will start by using 1%, and 1% gives us a dew point of 7 degrees. We will increase that to 2%, we get a dew point of 17 degrees. We will then increase that to 3% and saturation occurs. So we will then decrease that to 2.5 and we get a dew point of 20.89 and a relative humidity of 99.923. This tells us that the maximum absolute humidity is 2.5% before saturation occurs. Thank you for watching this quick guide on how to use the PST humidity calculator. More information can be found on the Process Sensing website.